Up to this point in the course, all of our modules have focused on the mechanics of solids. With this video, we begin a series of 2 modules in which we will study the behavior of fluids. Let's begin our study of fluids by asking, what is a fluid? Let's start by looking at some examples. Here I have a piece of wood. Is that a fluid? No, that's a solid. How about a rock? Is that a fluid? No, that's also a solid. Or my metal paperweight here, is that a fluid? Nope, also a solid. Okay, how about this example? I have a glass with some soda in it, so just ignore the glass and look at the soda. Is the soda a fluid? Yes, the soda is a fluid. Here's one last example. I have a balloon with some air in it. Ignore the balloon and just think about the air inside the balloon. Is the air inside the balloon a solid or a fluid? The air inside the balloon is a fluid as well. To summarize, I've shown you several things which are solid: wood, rock, metal, but I've also given you some examples of fluids. The soda was an example of a liquid. Liquids are fluids. And the air in the balloon was an example of a gas. Gases are fluids as well. So liquids are fluids, gases are fluids, and there are even other phases of matter, which we're not going to get into here, which you could also classify as fluids. But we still don't have a real definition of what makes a substance a fluid. What we would like to do is write down a single criterion which all by itself allows us to identify something as either being a fluid or not a fluid. So I'm going to show you a demo now, which will help lead us to such a definition. So you can see that I have here a beaker filled with water, and I also have this tube of food coloring. So I'm going to squeeze the tube so that a little drop of food coloring falls into the water, and we're going to see what happens when that little drop of food coloring enters the water. Okay. Now, you saw that compact little drop of food coloring enter the water, and when it did that, did it remain as a compact little drop? Well, it started out as a compact drop, but as the experiment progressed, that compact little drop got pulled and stretched into a lot of elaborate shapes. Let me do that again, as those shapes are kind of at the bottom this time. Okay, so you can see that as the process progresses, what started out as a compact little drop of food coloring gets pulled into a lot of complex and elaborate shapes. So how did that happen? Tiny forces acting within the fluid region pulled on that droplet and stretched and twisted it into all those complex shapes that you see in the beaker now. Okay, so that worked with 2 different fluids, the water and the little drop of food coloring. Would this work with 2 different solids? Well, let's try this. So let's say that instead of water and food coloring, I'm going to try 2 solids, a piece of wood, and now I'm going to take the second solid, the ball bearing, and put it on top. Now, do we see that ball bearing dropping into the wood and getting pulled and twisted into all those elaborate shapes? Of course not. So this gets us right to the essence of what makes a fluid a fluid. As I showed you in the demo, a fluid is a substance in which tiny bits of matter can start next to each other and then be driven far apart from each other by arbitrarily small forces. Liquids meet this definition, gases meet this definition, and as we saw in the video, solids do not meet this definition. So now I've given you a brief qualitative overview of what makes something a fluid or not a fluid. In the next video, we're going to begin developing the concepts we're going to need to describe fluids mathematically.